Seems like you guys haven't eaten yet. Good evening! Okay, alright, that's the spirit. Okay, so before we start, thank you guys, thank you everyone for attending today. Alright, I'm Nasir, will be your host or MC, whatever you call it. Alright, so we are from CNCF or Cloud Native. So also it's our sustainability week. Alright, for our sponsors we have Microsoft and Sujay is our PIC over there. Okay, alright. Did you guys leave the food just now?
Yeah.
How was the food? Food. Only one person answered. How's the others didn't eat? Oh, not enough? Okay, we'll make sure to put in more. Alright. Okay, thank you Moneyline for sponsoring the food for today. Okay, so our agenda, really quick, welcome note, like I explained just now, a look back, it's a 1 year anniversary for us. Alright, so our first talk will be from Magesh, alright. Second, we'll have a really quick, really short and sweet lightning talk. And our last talk will be from Sujay. Also, this you guys have to be really excited for. Okay, can anyone guess what's the prizes for today? Oh, wow, okay. Okay. I heard someone says, alright. So, our major or main prize for today will be a PS? PS5. PS5. Oh. Okay, unfortunately I can't, join. If I would love to, alright? Okay. Alright, so first prize, PS5. There's also a second prize will be a Nintendo Switch. Okay. Oh. First time, yeah? Okay. Third prize will be a really good SteelSeries headphones, alright? So all the prizes were funded by Mr. Magesh himself. First time I'm seeing an event where he sponsored full on out of his pocket. So thank you Magesh, yeah? Alright, moving on. Okay, why does sustainability, matters in the first place? Just a little bit here and there. IT sectors, I'm sure maybe, or almost everyone I guess, is from the IT sector. So it actually contributes 2% of your of our global carbon emissions. And the thing is, it's going to increase exponentially, alright? So looking up in the next couple of years, not even 10 years, 20 years down the road, it's going to be up to 12% by 2040. And something up more slow, I should say, it's going to be exponential right after that. So I think, make sure you do your part, take every single step that you can, just make a world a better place, alright? Just going a little bit deeper into this. So how do you actually reduce these type of energies? First, little bit on developer-centric side, you need to measure, have tools, measure energy, we can have a little bit more talks on this later on, alright? Reduce your code. If you're a software engineer or anything, you need to write really good code to be efficient. Don't use Python. I'm joking.
Don't use JavaScript.
Okay, alright. Okay. I'm sure I received lots of backlash, right? Okay, lastly, identify the working hours and environment. Okay, turn off your applications. Pretty self-explanatory. Okay, important part. We have something called tag environment support from Cloud Native. So what it does is basically you tag in your environment which aligns to our sustainability, goals. Right? So read out loud, just to be pretty basic, it advocates on develops and supports and help and evaluates environments, sustainability initiatives in cloud and cloud native technologies. Okay, so how do you actually do this? You're reading slide and you go like, what is this, man? I don't understand. This is what it does, or what we do, right? So we have communities which share about what we actually do. We have green reviews, so basically just making your projects over there a more greener place, right? So how do you actually join these kind of groups? Please do take a picture. Make sure you guys contribute in a very own way. I hope you guys can actually slowly pick up your more. Also, it's a good slide for C-suits. Okay, so if you want to present your bosses and whatever, this would be really good. Okay, moving on. Without further ado, it's 1 year of Cloud Native. Okay. Okay, you guys will be like, oh, 1 year? No, trust me, we went through a lot to actually reach this place, alright? So we started in 2020, if you guys know, COVID time, everyone was stuck at home. So the hype was there, but all of a sudden everything just shut down. Lights off. That's it. So it's restarted again in September 2023, right after COVID started, from our organizer, who is Magesh herself.
Shout out for Magesh.
Yeah, of course, Magesh.
Thank you.
He did lots of things behind the scenes, get this venue, get the sponsors and stuff, alright? So there's a lot of things going on. Our first official meetup was October 2023, and the thing is we started with like 100 members, and right now we are 1,200. So hopefully for more, make sure you guys, go around, share, tell other people, spread the word, okay? Hopefully for 2,000 and above. Alright, so we little bit more, we onboarded 2 organizers, 5 volunteers, including myself. Alright, interesting topics. We have very interesting topics from presenters. We have additional activities that are planning. So make sure you guys stay tuned. More giveaways. So if you guys attend more, there will be more, better, nicer gifts. Okay, and contribute. Okay. Alright, so thank you everyone for actually being part of Cloud Native, and I hope we actually build this open source community together. Okay, without further ado, I would like to invite our first speaker for tonight, Magesh himself.
So today I'm going to talk about Kepler. I'm not going to be too much technical. I mean, it will be very high level. Of course, there will still be technical things that will be involved, but there won't be any coding and so on. I won't bore you with codings. Okay? So the agenda today is we'll go through the problem statement, what's the issue with the current Kubernetes setup and so on, and what is the goal we are trying to achieve, and how Kepler will help us in this. And we'll also look into how to implement Kepler and what are the limitations, current limitations, because it's kind of a new project actually. So there are a lot of limitations, so we are going to look into that. So the problem statement. Yeah. Okay. So we need something that can scale efficiently. Of course, we have seen scaling based on CPU usage, memory usage, and so on. But we also need something that is more sustainable. So that is one of the issues that we want to solve. And also, there is a lack of visibility in terms of energy consumption when it comes to Kubernetes worker nodes and also the pods. So how we are going to get the analytics and how we are going to scale based on that. And is the current auto scaling is sustainable over a longer period of time? So how we are going to solve that? Okay, so what is the goal today is to reduce carbon footprint of all the worker nodes that we are trying to run for our Kubernetes, and also we want to have analytics, maybe a dashboard on over a period of time, how much energy consumption of the pods and the worker nodes and so on, how to scale the worker nodes efficiently. So that are things that we want to look at it today. So there is this tool, Kepler. So Kepler is a Kubernetes-based efficient power level exporter. So it is a CNCF sandbox project. That means it's very new project that just has been accepted into CNCF, and the number of adoption is still quite low. So that's why it's in sandbox project. So once it becomes widely adopted, so it will go into incubating, and it eventually one day, hopefully one day, it will become a mature project like Kubernetes or Helm, Argo CD, and so on. So below the surface, I would say, so Kepler uses eBPF, Berkeley's packet filter, like many other cloud native tools like CDM, for example. So what it does is it will try to probe the lower level statistics from the Linux kernel, such as the power usage, and export them to into metrics that we can analyze or we can visualize through dashboard and so on. So like any other cloud native tools, is also written in Go. but there is SDK for C++, Rust, and few other language I can't
No
remember
Python?
right now. Python, I don't think so. Sorry.
Not power
Maybe we
efficient
have
enough.
in the future.
Not power efficient enough.
True. Yeah. So the key contributors for Kepler is Intel, IBM, Red Hat, and there is another company as well, but they have they've shut down the operation. But so it's brief work actually. Yeah.
Oh.
Yeah. So yeah, and then maybe the naming of Kepler is Kubernetes-based efficient power level exporter, right? But it's also possible to run this in a non-Kubernetes environment, like RPM, what's that? RPM package or that package or whatever. So you can build from source or download the RPM package from the releases from their GitHub, and you can run on your
Raspberry Pi.
yes, Raspberry Pi or any Linux-based servers, or But that's not our focus today. But our focus is more on Kubernetes. Yeah. Oh, okay. So before that, I'll go slightly into detail what is eBPF. Like I mentioned, extended Berkeley packet filter, but it is actually a misnomer, I would say, because initially what BPF meant to do was to do packet filtering, networking level. So they started in BSD and then ported into Linux. But eventually it expands from there, not only packet filtering, so it can do other stuff. So extended Berkeley packet filter is a misnomer. That's my opinion. So what eBPF can do is extend the capabilities of the kernel without you involving directly contributing to the kernel code itself, because that is a lot of headache, but we'll go through that later. And it runs as a sandbox in the kernel, and it also can run on user space as well. Thank you. So kernel that before eBPF, how you gonna make changes to the kernel? So you need to contribute to the kernel repo. So it's a tedious process. You need to go through the pull requests. You need to make Linus happy. You need to be happy before it gets merged. If it's not happy, probably gonna bash you.
And get the middle finger.
Yeah. Yeah. So it is a long process if you want to contribute to the Linux kernel. So, and also it takes longer time for it to be merged. Normally, once it get approved, it will take 9 to 10 weeks to get merged into the mainstream. Probably go to RC release candidate and then go to stable. So this process is very tedious and very long. So eBPF reduces this time. And also debugging kernel code is a very challenging process. And every time you make changes to the kernel code, you have to recompile and do that. It is a headache. So then comes eBPF. Okay. So you can develop eBPF independent of the kernel, outside of, because you don't need to have the kernel code itself, but you need to know how you're going to plug in to the kernel. So, and you can write a smaller self-contained program. So you don't have to write everything from end to end. So what is your objective? So you write that, and then you plug in. You can integrate and run into the like a sandbox in the kernel. So it also, other than that, also provides like tracing. So whenever there is like a syscall, so the eBPF can trace that, and we can gather more information from that. Like I mentioned, it doesn't need recompiling the whole kernel. You just need to recompile your eBPF, that smaller piece of code, which will reduce the amount of time you spend on coding and fixing the issue and so on. And it also, in terms of security, it provides you a version that will not cause kind of kernel panic, for example. So it will generate something safe, but if it couldn't do that, the compiler will throw an error for you. asking you to make changes so that it could run safely anywhere, including the kernel and user space. Okay. So just quick overview. I don't want to go in detail here. So let's say you have your process and there is a syscall that's happening. So there will be like a hook that is attached. So every time there's a syscall, they will go through eBPF. So it will collect whatever metrics you want or things like that. Or you can do as like a probe, attach like a probe to the kernel or user space and gather whatever details you want or any changes that you want to make. It can, I'm surprised actually, it can even attach directly to the device driver. Yeah. So this is Kepler, this whole part here, except this is external. So I'm not going to go into detail again because I myself am not very familiar with everything. So most important part is here. So it reads the sensor data or the metrics from GPU, for example, or from the CPU, running average power limit. So all these details, it can collect and send as a metrics so that you can integrate into your Prometheus to store that, and then you can run your PromQL or whatever to gather those metrics, put into your dashboard, and then you can use like a ML model to learn about the energy consumption of these pods or worker nodes or so on to scale your pods. Schedule your pods into worker nodes that are efficient, for example. Yeah. Next. Yeah. So I'm not going to go into the code. Just quick overview how we're going to install Kepler, just like any other Kubernetes tools. So you just use a Helm chart, or if you want to really use Kubernetes manifest, go ahead. But Helm chart simplifies your work. Or if you're not running in a non-Kubernetes, if you're running in a non-Kubernetes environment, you can use the RPM package or build from source into a .dat or any other packages that you want for your distro, and then install it from there. So just a quick steps what you need to do to have Kepler. So deploy Kepler as a daemon set, so it runs on all the worker nodes. Configure Prometheus separately. So Prometheus will gather those metrics and export that to your monitoring or observability platform, and then create the dashboard in your observability platform like Grafana or whatsoever, and then you can test the workload of the Kubernetes workload with different metrics, CPU, GPU, and so on. Yeah. And I/O reads, block device I/O reads, and so on. Yeah. So like I mentioned, Kepler itself is not enough. So you need to have Prometheus, you need to have an ML model attached so that you can estimate the power consumption of the pods and also the worker nodes. And then maybe you can, not maybe, you should attach like a scheduler or autoscaler. So scheduler is to schedule your pods into energy efficient worker nodes, and autoscaler so that it triggers worker nodes that are efficient from the metrics that we have collected. KEDA, there is also a PIGS project called PIGS, Power Efficiency Aware Kubernetes Scheduler, but it's not a very active project right now, so if you want to contribute to that, go ahead, so that it becomes alive again. Right. So, what we are trying to achieve here. So, get Kepler to export the metrics, display the metrics in dashboard. So, use the metrics in ML to estimate the power consumption, and then from there, either schedule the pods into energy efficient nodes or trigger the autoscaler, like I mentioned. Yes. So, yeah. And finally, the limitation. Since it's a very new project and it's a sandbox project, it works better on dedicated instances rather than shared resources, shared instances. Sometimes when you schedule your worker nodes, it could be scheduling into shared instances in your public cloud and so on. So it might not give you the accurate metrics. So that is one of the issue right now. So it is more efficient on dedicated instances. For architectures, in terms of CPU, it's only limited to Intel CPU right now, and for GPU, it's limited to NVIDIA. So it's very limited, but of course, since it's an open source project, you can contribute, you can extend the capability. So go ahead. And finally, there is no roadmap for Windows. Although if yeah, because
Why will you even need on Windows? Why do you even need on Windows?
because we don't know. Some companies might have very
They run.
very niche requirement to run their Kubernetes nodes on Windows. I don't know.
What the shit?
Yeah, probably they have legacy codes. They are adamant to run on Kubernetes, for example. So, but for now, for Kepler, we don't have roadmap. But based on what I saw, based on what is going on in Kepler, so far we don't have any roadmap for Windows. Although eBPF is available for Windows. So, like I mentioned, probably it's because of not many people using Windows as a Kubernetes node. So we might not see that. I don't know. Okay, summary. So Kepler is a good starting point for running a sustainable Kubernetes only if you're running on-prem, or if you're running on public cloud on dedicated instances, not on shared instances. And yeah, and it's also a good way of reducing the cost, because you will be finding an efficient worker node to run your workloads. So not only you are saving the environment, you are also saving the money for your company. So and it's open source. So go ahead and contribute to make the project even better. Yeah. Thank you. So any questions?
Okay, we'll open the floor to Q&A.
I think you are running a ML model to predict the, energy efficient worker node based on the metrics, right? For running a ML model, you need a GPU. How about, because that consumes energy, right? Whether
Yeah.
the trade-off has been done.
Yeah, for
my
now-
question is like,
For now, that's the only way to do it. But yeah, it is kind of anti-pattern or anti-competition.
okay.
Yeah, I don't have a better option actually for now. Yeah. Maybe LLMs that are optimized, maybe a smaller models than like very dedicated models rather than a large model. That's the only thing I could think of now right now. Yeah. Yeah.
Hi, my question is, have you seen any successful implementations of using Kepler and it actually have something that that is significant enough? Because from what I see, Apple, they say they are doing it, but it actually I don't feel anything. So
Yeah, actually, yeah. From my side, I haven't fully explored yet, but I've seen talks that in Japan, I guess. So they try to compare actually two LLMs running on Kubernetes. So they did actually a good comparison. I couldn't remember right now, but they compared between Gemini and Llama. So they really did use Kepler to see which LLM was more efficient. So they did that comparison. I have to go into details into the talk to know actually what was the study. So right now I couldn't get much into the detail. Yeah, but they did that study this is in Japan.
Anyone else got any questions? Okay. Okay, all right, we have one more.
What if we like use Carpenter, right? And then we only allow it to schedule like efficient nodes.
You can do that, but the thing is, for different kind of workloads, right? So whatever, let's say, for different languages, different worker nodes might behave differently. So you cannot like predict it by yourself that these are the worker nodes that's going to be efficient, right? So you need to run, you need to study which worker node. Probably for certain languages, some worker nodes, like let's say Intel architecture, for example, Intel CPU will be better for some other language. Could be some other like ARM-based CPUs will be better. But so to do that, you need to run your workload your pods first, and then you based on the metrics, based on the analytics, then you decide which is more efficient. Yeah. Or you can do that study first. You can do your efficiency study first, and then you can decide with Carpenter. I mean, once you have reached your conclusion, then you can do with whatever you mentioned with Carpenter. You just limit to this kind of worker nodes with this capacity, for example.
Okay, any other questions from members of the floor? All right, we'll go once over here and then to yours next, yeah?
So what models are currently being used? ML models?
Yeah, I haven't reached to that part yet actually. Because I'm still exploring the project, so it's in very early stage. So I'm exploring for the sustainability week. So it's still in early stage, so I can't give the detail as of now. Sorry about that.
One question regarding the metrics that this captures. How deep or how far-reaching are these metrics? So let's say, for example, certain let's say clusters run in certain parts of the world. They would use different sources of energy, and different sources of energy would contribute differently to the carbon footprint. So does this go that level and capture that aspect of it, or is this not quite? Maybe it just captures amount of energy, so how many kilowatts, and that's the end of, or that's the extent of what this captures.
So far, based on what I heard, it's more on how much energy it uses, not on the type of what's that?
The grid that it's connected
Yeah,
to, and so on
yeah,
and so forth.
yeah.
Okay, thanks.
Alright,
Hi. I heard you mentioned that you should use it in dedicated clusters only.
Dedicated VM or whatever, yeah,
Right.
worker nodes.
Right. Have you read anything about running it on spot instances? Or is there any recommendation given by the spot instances?
If I'm not mistaken, you're talking about in AWS, right?
In general,
in
there
general,
are spot IO.
But when it comes to spot instance, correct me if I'm wrong, is it still dedicated? Is it a dedicated instance? If it's not, then
It's not.
Kind of. I mean, but you.
at the end of the day, it is all about if it's a dedicated instance, it is. But then if you're running on spot instance, you might lose the instance whenever.
So then I would.
So
I
at
would
the end
need
of
to
the
have a-
sorry, at end of the day, it is not as efficient because you still have to reschedule your pods to another instance.
Okay. Fair enough. Thank you.
Right, do you have any other questions? Going once, going twice, or anyone else? Okay. Okay, alright, thank you so much, Makin, for your questions. Alright, before we move on, give me a short break over here. Okay, so before I move on to the next talk, which will be very interesting, I have a very short explanation, story, whatever you want to name it. Okay, anyone heard about butterfly effect? Butterfly effect. Okay, there's one over here. Butterfly effect, anyone? Okay. Oh, seems like everyone knows about the story. Okay. Chaos theory. Chaos theory? Okay, alright. So if you, okay, there's one. Okay, that's good. Okay, for you guys who don't know, since we are in sustainability week, there's someone called Edward Lawrence. Okay, so he's basically a meteorologist. Somewhere around 1960s or 70s. Can't really recall. So what he actually found out was that he did a study, and he said that a small, how small of a wing flap a butterfly is? Yeah, it's like nothing, right? No one can actually feel a flap, a worm or wind from a butterfly, right? Everyone agrees on this, right? But he said that something as small as a butterfly, a whip of a butterfly can actually result in a hurricane. Such small nuances or such small things can actually, have adverse or big effects. And I think this goes to our week today. This is what we're trying to explain. So every single small thing that you do, no matter even if you realize it or not, will give a very big impact later on. Alright, so moving on. For our next talk. Okay, this will be very interesting. Okay, anyone knows about the DNS thing? DNS thing, what's going on?
It's always the DNS.
It's always okay, it's always the DNS. Okay, so a little bit of background on this. So before I introduce Sam, he's actually from CNCF project. So his company or his role goes into transparency or works with advocates the government into publishing data and being more transparent. So this comes where Sam is actually the PIC or the person in charge who goes into all of this to make our DNS more transparent. So without further ado, I would like to introduce Sam Ng from CNCF project. Round of applause to him.
Give me a moment, I need to set up my PC.
So meanwhile, the short break, we must setting up. Make sure you guys, pay attention and stuff because, one of you guys is going to win PS5 today. Okay? I'm sure you guys are excited. Another one, Nintendo Switch. Right? So are we ready? Let's give it a moment.
Okay, hi, good evening. Yeah, this is my first time actually at CNCF. So I'm here to present the lightning talk. I only have 10 minutes, so I've prepared a lot of diagrams. But a bit about myself. So I'm actually a knowledge management and community officer at CNCF project. What that means is I'm a public front or interacting with people, right? But a bit of my background, before CNCF project, I previously worked as a cloud security specialist at the local telco in the cybersecurity department. I've also worked as a DevOps engineer and system engineer in various industries, including domain registrar, fintech, proptech, and others. So that's a bit about my background. So today I'm just sharing quickly about CNCF project. So we're a non-profit civic tech initiative, and we use open technology, open data, on open government, and we use policy analysis to make important information available to the general public. So it's a lot of words, but generally, for most people, if you have been aware about the DNS issues, some of you may have seen this on Twitter. If you're active on Twitter, you would have seen it. If not, you would have heard of us from other what do you call, other channels like the news. Okay, but a bit of history. We've been around. Senior project has been around for. We've been around for many years, right? We started in 2011, and we've been vocal since 10 years ago during the Najib administration. So this is like a EFF, Electronic Frontier Foundation, the one that advocates open source for Linux, and this is like a 2015-2016 article. So we've been vocal about that. And this is just some background on CNCF project. Okay. But why does CNCF project even talk about this? Or why did it come that we brought this to the public information, right? We run this project called the Internet Monitoring Action Project. In fact, we're having a launch tomorrow. But it's a regional project that measures network interference, and all the data for all the countries, not just these countries. Most countries where people run this UNI software, they will have, this is all available as open data. Okay, you can query, you can check, and all that. And if you're interested in that, you can scan the QR code. I'll just leave it quickly, because I think some people might be interested to look at it. So it'll bring you, I think, if I remember correctly, it'll bring you to the UNI Explorer page, and you can look at which things are censored and which are not. So that's why people talk to us about it. And because, so if those people who know, we were cited, probably, I think the first was Malaysia, Guinea, then Soya, Chinchao, Laoya, and so on and so forth. And we, some of my colleagues were also interviewed in the others. Okay, but what am I talking to? Why do I even bring this up to everybody? Yes, I think the problem, maybe the policy has been U-turned, right? But I'm just highlighting maybe some of the technical aspects, and also if you're engineers, other angles that you can, I hope maybe it's useful information for some of you. Okay, but this is just a diagram. Because when all this happened, I think it was very hard to find easy to understand graphics. So this is a graphic that easily explains what DNS transparent proxy is. But I'm not just talking about DNS transparent proxy today. I want to bring your attention to why this thing became a big problem. And one of the big problems is because of encrypted DNS. And encrypted DNS is it's not like traditional DNS, and that was why there was a lot of major disruptions in all of the IT systems, because what they were trying to do interfered not with just with basic infrastructure, but the encrypted DNS crosses over a few other things. And I think one of the challenges is because you had to use the ISP DNS, and I mean, based on my previous background, I think if they didn't perform the U-turn, this would have even longer term effects. And then, but anyway, officially the news report about redirection policy only came out actually only on 5th September. Okay, and this required enterprises to, you have to comply by September 30th if this thing was not, reversed. So that's, and we only got the official reversal on 8th of September. So, I mean, I think I already covered this, but this is a bit more small picture based. So, I think they did this in August, your traditional DNS. The problem was, I think we recommended DOH and DOT. If you've seen our update, we recommended DOH, DOT as a way to work around it, right? But they thought, let's just, I don't know, just do the same process that we did for traditional DNS, and that's a problem. Anyway, this is an article where I'm getting all these diagrams from. It's a It covers a lot of other stuff which I won't go into. We really don't have time, but it covers about the other broader landscape. But this article is where I realized beyond DOH and DOT, there's a larger landscape of encrypted DNS. Okay, and I think some who are Apple users would obviously would have related to the oblivious or may have researched something about that. And so there's also the evolution of SNI and ECH. I won't go into it now. I'll just briefly speak about it later. And I think one of the bigger things that we saw on our Telegram group, so if you saw on our Twitter, we actually invite people into our Telegram group. Before that, we only had like 17 people for the past few years. And because of this, we grew to about 200. I think as of today, we have like 204 people on our Telegram group. But we noticed like in early September, there were people, not just on the Telegram group, I think on Malaysia and other places, that their zero trust setup is broken. So, yeah, so coming back to this public cloud resolvers, so why is this important now? Because I think techies, people who are, you are a bit more, what do you call, technically savvy, you are aware about this, and some of you also, I'm aware that you implement this in your house for safe browsing. And when this thing was done without consultation, it broke for some people's house. But I also want to highlight other contexts, right? Because I've also worked a bit in the industry. I also have friends who also work in the private cloud. So just want people, so like today's session is more on question, like some of my findings, and also maybe a bit of food for thought for everybody, right? If this thing wasn't reversed, what is going to be affected? Your DNS request will be hijacked here, but who will have to figure out more questions or solutions? Maybe if you're on the public cloud with a Malaysia location, not, how do you say, you have AWS, Microsoft to back you up. But what if you have a private cloud? What if you run your own Kubernetes cluster? So you have more things that you potentially have to think about that's not adding value to your organization's business, right? So just think about that, and definitely your compute, your containers, your servers, and just now everybody was joking, it's always DNS, right? So think about that. So this is a slide where this is a bit broader beyond DOH and DOT, right? And also from this, I'm going to bring up a bit more on the IETF, RFC, which I will explain later, but this thing became official standards in these dates, May 2016 and October 2018. But I mean, if you're on Cloudflare's.org, you would have seen something about ESNI, and ESNI is now outdated and superseded by ECH. We don't have time to go into it, but if you were, during this period, you were looking into all these things, you might have heard about DOQ, DNS over QUIC protocol, and the earlier Apple. So these are officially internet standards, but this officially under the Internet Engineering Task Force. They are still proposed standards, experimental and proposed. So I know there's a lot of stuff to digest, but in summary, encrypted DNS, this is a good site to like consolidate some of the things I mentioned. You get the links to the RFC for DOH and DOT, and it also, but I've just pulled out the most like important parts, which are, if you're an engineer, you would definitely, just now you're talking about working groups, right? So these are working groups that discuss these protocols, and these are open. When they're discussing all this DOH, DOT, it's actually available on YouTube. I think it's under, you search IETF or like IETF 105 to 106 or 7. Okay. And just a quick slide about what are, if you don't want to get into like developing your own standard, open internet standards are great. There's a lot of standards, but IETF is the one I'm focusing on today. And this is just a link about explanation about the technical documents called RFCs. So some of the other articles you will see, they refer to this. And I just bolded like the internet standards and best current practice, just because I'm going to cover a bit about it. So yes, we've already gotten past where the policy is reversed. But I would like to invite you to think, what if it wasn't revoked? If it wasn't revoked, today, you have to read, you will definitely likely have to read this document under this section, which covered this thing called middle boxes. So if you're not from cybersecurity, you don't come across this, or you don't come from network interference. But middle boxes are where, you know, when you do all this interception, that's what these middle boxes are. And why I'm highlighting about IETF RFCs, because a lot of the things that we would like to know related to all these standards, it's already documented. So you don't have, I mean, you can do your own research, but just sharing. There are working groups that are working on this all the time. And then this one's on DOH. There's nothing as much on DOH other than stuff on privacy concerns on the servers. And then for this, I'm just highlighting one of it called best common practice, where they talk about DNS over TCP filtering risk. So when you filter it, it's recommended to not filter your DNS for your DOT, right? And there are good reasons for this. But read this RFC, and you can learn a lot more. They tell you about a lot of things. I think I didn't include one RFC which also explains, like, when you retry, like why did the telco even have to reverse? Because I suspect, I don't have proof, we suspect that the DNS servers were trying and failing because of inconsistent, because when they intercepted, it may not return the right thing, right? So that, I suspect, it might be what has happened. But I don't work at the telco anymore, I don't know for sure. But I'm also sharing this for public info, so if you have friends who are working in the telco, share them this information and, you know, find out what they need to do. And so I don't have time because it's only 10 minutes, but also just because just like some experience. So if we have time, I'll probably talk about a bit, maybe whether some of these aspects you need to work on. I think if you go and search on the internet, there's a lot of stuff, but I think most likely these are the areas where you have to start looking at DNS parts. And also don't have time, but zero trust. So for people who don't know what zero trust is, traditionally everybody knows what VPN. Now these lot of cybersecurity departments are looking to SASE, zero trust kind of environment. So that's their kind of detection. Also, if you're using stuff like Cloudflare and Tailscale, to some extent, is using something similar type of architecture. So what that means is there's some of these elements. So I think I've almost come to the end of it, but generally, what is the impact of all this? Because I think some people don't have a Malaysia Kini subscription, but Malaysia Kini wrote this, not me, I didn't write this. They wrote that maybe future cloud investments may be impacted. True or not, honestly, I don't know. It's somebody's opinion. Okay. And then I'll just end the talk. I'll just call back the encrypted DNS backsheet, right? Because I just want to highlight the issue. Main issue isn't about blocking and all that. The main issue was not really understanding encrypted DNS properly. And in this fact sheet, they mentioned that you need a proper informed multi-stakeholder discussion and what you block and so on and so forth. There's a lot of things to think about, but it depends on your circumstance, risk profile, whether you're doing it at the national regional level. Are you a DNS resolver operator? If you're running your own infra, this will be something you have to think about. And if you're an enterprise MNC, this is also something you have to do. So if you want to learn more, you can, if you want the slide or something, you can contact me. You can also scan the QR code, you reach somewhere to my LinkedIn. So far, anybody has any questions? Maybe.
Hi. So, given the current circumstance, do you see this kind of redirection policy coming back? That's my first question. The second question is, in the event that we really implement DNS redirection, right? What, like, do you think that maybe like some hackers or whatever shit will go DDoS that DNS server and basically bring the entire nation down?
Okay, do I see them doing this? I think for now, this current development, the answer is probably no. But who knows if the government changes? I mean, I don't know. To your second question, I think some of these things can happen at any time. So, I mean, that's my answer. It's not dependent whether it takes a DNS hijack to screw the DNS, but yeah. But because this was done so publicly, so there are more people globally who are aware about how things are and may capitalize on it. So, and part of the reason why I'm also sharing about IETFs and RFCs is also like for us to equip ourselves, right? I'm not here today to like share and ask you to fight against the government. No, I'm sharing that there are concrete engineering things that we can do, we can share, we can learn. So that's more of my angle. And maybe if anybody has other questions, maybe the rest can give some feedback. If as many of you can scan the QR code, can give me some feedback on the lightning talk. And I've also really want to collect data if your work in any form was affected during the DNS redirection policy implementation. Whether it's CI/CD, Zero Trust, if you're willing to share the details, go ahead. We can discuss further how you can go about it, but yeah, I appreciate if as many of you can give feedback because I don't think anybody
question from my end.
Sure.
You mentioned about redirection, of course, and let's say I'm a private cloud provider, and in order I realize, okay, some of the countries like Malaysia is implementing these kind of DNS proxies. Would you think that I initially started my DNS redirection from a country where there's no such policies, and all of my clients are coming in? So most of the DNS is coming actually from the other hop, from the other country then. So what do you think about that then? Let's say as a private cloud or my own cloud, so let's say Amazon or Microsoft, whatever, they open a cloud services, rather than redirecting from here, they redirect from somewhere else initially.
Actually, I'm a bit confused. What are you asking actually?
The redirection basically not coming, doing it from here, from the AI space, but over the VPN or over any of the protocol, you're getting the redirection of the DNS via a foreign country from other countries than initially. So do you think it would be a good practice to avoid these kind of DNS proxy escaping?
Let me try and answer that. I'm not sure if I'm going to answer you correctly. A lot of times DNS transparent proxy, this kind of hijacking, it's very common. It's commonly done in corporate networks. If you are part of a infra team or cybersecurity team, this is normal.
Basically,
Yeah.
you do your own transparent, make a transparent policy
Yeah.
where you're not producing any censorship. Basically, it's going back to all open then. So do you think it would be a good practice?
I think I understand the question.
I don't understand.
I think I understand the question.
Are they are the people accessing this private cloud?
Yeah, cloud. So rather than relying on the redirect coming from the country, they implement their own transparent proxy. But in the end, it's even though it's transparent, but it gives out the same result. It's not censoring anything. In that case.
Because normally it's normally done by at the country level. So I'm not sure how this applies. Yeah, unless somebody could clarify.
Yeah, I think I understand his question. So basically he's asking that what if you did your own transparent proxy within your own network, but your transparent proxy will definitely need a DNS resolver, right? So instead you tunnel through the entire government network, then maybe like you tunnel all the way like to a US AWS instance, you resolve the DNS there, return the results in. So I think he's asking whether this is a good practice or not. Am I right? Yeah.
Okay, for Sina project, we are of the stand that you shouldn't need to do this because if you have to do this, it's a lot of work. And if you think about it, if you're doing engineering, this is what value is this giving you? So that's also one of the reasons why we run the IMAP project. And also we voice out about this is because yes, we know people can VPN. We are aware that VPN can bypass, but we are not. What we want is to hold the government accountable. They said they are blocking it because of this reason. Why should the other things get affected when they told us it's not getting affected? That's my answer to that.
We'll take one more last question from the floor. Anyone would like to go? Okay, going once, going twice. Okay, thank you so much, Sam. Very informative. Okay, so I hope you guys leave your feedback. So if everything goes well, hopefully Sam will give like a longer one hour talk, so he goes into depth of what he does. Okay, so without further ado, I would like to introduce our second speaker for today, Sujay. A round of applause for him.
Hello. Hey, good evening everyone. Sorry about the first half. We were more concerned into the sustainability side, so we didn't switch on the AC for you. So, as the theme is about sustainability, I will just start a brief introduction about what Microsoft does around the sustainability part. So, in terms of Microsoft, we already had started this sustainability within our organization way back 10 years back. So somewhere in 2009, that's where we started about the topic of sustainability with our carbon emission reduction. And that's how we started. And there have been certain initiatives, and going forward, the goal for us is that by 2025, we are trying to operate with 100% renewable energy, and by 2025, protect more land than Microsoft uses. And we have set a goal for around 2050 also. That's our kind of long-term goal. So by 2030 we are trying to achieve become a carbon negative, kind of zero waste, and water positive. So these are different terms you will come across the sustainability thing. And Microsoft does offer a few services, software as a service around this one. The one main, if you want to explore, it's called Microsoft Cloud for Sustainability, where you can gather all your ESG data and you can build on dashboards and everything within the Microsoft ecosystem. It's not just Microsoft, you can bring in data from other clouds also, whatever your cloud usage is. And the other is Microsoft Sustainability Manager, which is also kind of a SaaS service from Microsoft. So these are basically two different services for sustainability side on Microsoft. So the talk what we are going to listen about for the next half an hour is something called KAITO, which is kind of an open source project from Microsoft. It was released, I think, during the last KubeCon 2023 in Europe. As the name says, KAITO is like Kubernetes AI toolchain operator. So we'll see how this project basically helps to utilize the GPU resources in a bit efficient way. So I think there was a question from this gentleman, like how to efficiently use the GPU resources. This is one of the projects that would help you in your AI projects. So just to give you a bit of background, like if you had been working in the cloud, if we go back like 3 or 4 years back, everyone was like migrating to the clouds, and the theme was like, let's modernize our applications, let's run it on containers, let's use Azure like functions as a service. So that was the theme 2-3 years back. Now if you see the hype, it has changed to AI. People want to implement mostly AI stuff on the cloud. So that paradigm shift you have seen, like from the modernization to make AI integrated into application, and that's where you are basically making your application intelligent enough so that you can talk to the data what you have sitting in your environment in a natural language, and basically enhance and streamline the automation around it. So that's what has been happening with the last 2-3 years, I would say. And there are many services from respective cloud providers for this, but it's not easy to adapt those things. So we all have been hearing about this AI stuff. Just raise your hand, anyone working on AI project in the cloud right now? Okay, quite a number of people. If someone would be interested in sharing some pain points, going to the cloud and working on AI.
Actually, okay, for my case, we are trying to evolve a model that actually call as workbench. Okay, it will be like replacing knowledge-based models. So we would like to have an automated or co-pilot AI-based assistant agents. So the pain points we see here, collecting the information and also turning them into a prompting.
Okay.
That's been a challenge. And it's very fresh. I think the idea of creating the prompt and feeding into the mechanism, it's been a challenge for us.
Okay. Thanks for sharing. Anyone?
My use case is like we try to automate the threat modeling using LLM models. Hope you know the threat modeling concept. See, after we developed the project, and when we deployed our LLM models in GPU, we started observing a performance lag, like it's responding to only one request. If there are concurrent user, it's not responding to the second user. Even we procured some powerful GPU, so we face the performance issue. And moreover, if the length of the prompt is like more than 100 words or 150 words, we are not getting the right response.
So these are the models you are trying to develop in-house?
No, we used
Is the Nama 3.
We deployed on Databricks, so it costs around per day, it's around 1000 USD. So it's not really recurring, it's around 10 rupees per day.
Wow.
It's too expensive.
We spend a lot of money.
Okay, so if you see, like you heard from 3 people, so there are challenges still when you try to move your application and integrate AI into it. So I will just note down some of the points over here, which kind of resonates to the points what were mentioned here. So if you see, getting started is very difficult. The development around it, people don't understand how to get into those development activities because either they may be lacking the documentation or they may not have the proper knowledge to get started with. So it may be intimidating for them to start with. And then when you start with the context, because all those open source models which has been developed, it's not on your data, right?
Yeah.
So then you need to get trained with your data. So that context setting is something which is missing with open source models. So, and the other challenge is like when you try to deploy all these GPU workloads, it's basically a kind of a big task. You need to choose the proper GPU instance and to which model you are trying to get integrated into. It needs driver settings and other stuff, which are kind of a little bit on a hard side, I would say. So, when does open source make sense? So, all these models, what the cloud service providers are offering, is kind of their thing. So, we are basically kind of renting it out for our use. But what if we switch the context to open source thing? Okay? So there are many open source models which are basically, if you go to Hugging Face, you will see many open source models around it. So the first thing is that when you switch to open source model, you are basically avoiding that vendor lock-in. So I'm not subscribing to a specific cloud provider, rather you are consuming open source models. That's one of the main advantage. And then basically you can try to develop on top of it, and the basic modeling which happens, learning thing is basically in your environment. So you're not exfiltrating your data to outside world. So that's one thing. So those are like the security and the data residency things what we are trying to solve with the open source LLMs. And those developing with the open source models, it's not that easy. If you see some tweets from Kelsey Hightower, you will see that he's also referring that he wants that to be running locally and close to the data what I am owning in my environment. So there's an open source project which is called Olama, which helps basically in this your initial development efforts. It has also a better integration with Docker Desktop. So if you're trying to run those in containers, that's a good way to start with. So what's the best platform for AI? So I would assume that most of the people have started adopting to Kubernetes now. So definitely with those infrastructure which you have already invested in, I would say Kubernetes is definitely an option to start with in your AI journey. So the reason why we would prefer to run LLMs in Kubernetes is again a specific thing. So you already have those Kubernetes environments set up. That's the first thing which is running in your environment, and why don't we make use of that environment which we have already spin up. So that would basically help you in your I would say you already infrastructure set up. You can just consume the infrastructure what you have set up. And as I said, the Hugging Face is basically the repository where you can find all these open source models. Okay. And in terms of Kubernetes, if I just talk about the Kubernetes platform, okay, so we have all these features available, which is scalability. You can basically dynamically scale or horizontal scaling you can achieve within Kubernetes. Then you have resource optimization. You are basically running your models in a container. You would have already developed a CI/CD process around it. So you are basically known to how to deploy those things into the environment. And various other features what Kubernetes provides is basically your monitoring and logging, your data management stuff. So why don't we start with Kubernetes? It's already known to us, right? But even if you start with Kubernetes, there's still problem. So even though I'm running a Kubernetes cluster, when I have to do some data modeling or inference, I would still need to provision some GPU resources. So for each model that you're dealing with, you will be basically have to do a fine tuning, like the device drivers installation on the GPU, how to talk to those GPU instances. And then, like for this talk itself, I basically requested a demo environment. So the reason I got back is that there are no enough GPU resources in Singapore area. So I couldn't set up a demo environment, but fortunately, I have some recordings to show you. So that's kind of, you don't have enough resources everywhere in the cloud provider also. There's very limited which is available. So that's where we kind of looked into all these issues and made this project which is called KAITO. So what we are doing is that we are still leveraging the Kubernetes platform, and basically we are developing a set of tools, deployment tools, which would help you to work with the existing Kubernetes platform. And in terms, like, you will get a proper defined workflows, how to deploy those workloads onto the Kubernetes, LLM models onto the Kubernetes. So let me walk you through the architecture of this. So if you see at the top, the blue box is your Kubernetes server. So what KAITO brings in is two CRDs. So one is called the workspace. So workspace is where basically you will tell the Kubernetes cluster that I want to work on a specific open source model, and this is the GPU instance what you need to use. So once you pass that as a parameter, which is basically an YAML file for your deployment, so you will have this custom resource, it will basically make a call to the node provisioner. So the node provisioner is basically using the Carpenter at the back. So Carpenter is another open source project which was basically from AWS, and then Microsoft had also developed on top of it to work on our AKS cluster. So we make a call to that Carpenter API, and Carpenter knows how to auto provision those GPU resources as and when needed. So basically what you are doing is that you are not keeping running the nodes which you want every time. So when there is a need to do some modeling or inferencing, that's where I will go and create a workspace which is basically an environment for your development. And then I will say, this is my need. So it will basically make a call to the other CRD, which is the node provisioner, and do the provision for you. And that's basically the whole gist of this. So that's how, so it will bring up the specific GPU nodes, and you can basically make a call to your private registry or the public one. So the only new thing in this is the bottom box, which is basically the custom resource definition over here. So, as I said, why are we pre-provisioning it? So the thing is that when there is a need for you to do the training or do the inferencing, that's where I will go and define this workspace and create the resources. Because for doing the auto scaling, you will have to basically provision the node pre-app. Yeah, so that's kind of a waste of thing. resources for us. So when there is a need for us to do the provisioning, that's where we will go and create the workspace and do the deployment. And Carpenter being an open source project, so that's not tied to specific, like right now, it only works for AWS and Azure. So it's also another, so there is no vendor lock-in. Yeah. So what I'm saying is that if you're developing something project over here on the Azure platform, it can be easily portable to AWS also. There is no vendor lock-in in that case. So since the starting of the project, it's not been adopted by the other cloud providers as of now, but we are talking to other cloud providers, being an open source project. So you will see soon this coming into other clouds also. So if you see this kind of YAML definition over here, so there's the first box, what I'm trying to create. I'm creating a custom resource definition over here, which is of a kind, workspace. So I'm saying that I want to do some inferencing and use standard NC, which is kind of a VM type available on Azure side. So before I go ahead, anyone experienced working on Azure Kubernetes service? Okay, for the sorry? Yeah. Yeah, that runs on Kubernetes. Okay. So for the audience who haven't worked on Kubernetes, AKS specifically, let me just start with this thing. Is that visible?
Roger.
So if you are starting with Azure Kubernetes service right now, so I'll just walk down through the steps what's involved. So if you are a CLI person, you will need to basically have these add-ons enabled on your CLI, which is basically an extension on your CLI. Now, when you start with AKS, you have to specifically say, register the resources on your subscription what you have. So what I'm saying is that I want to use the AI Toolchain operator. So you see the preview, it's currently in preview, so that's the reason you see it preview over here. So when you enable this, it basically helps you to create those custom resources what you see on the Kubernetes cluster. And then these are basically a few steps to create. So over here, I'm creating a cluster. And if you see, I'm passing an option called AI Toolchain operator. So once you enable this one, that's how the KAITO feature gets enabled on your Kubernetes cluster. Okay? And there are extra parameters which basically is for authentication purpose. And let's say you already have an AKS cluster already running on your environment. So this basically, you will go and run an AKS update command on this. So once you have that cluster provisioned, you need to basically connect to the cluster, and then I would say the workflow becomes similar to what you work with any Kubernetes platform. So kubectl get nodes basically gets you all the nodes which has been deployed in your environment. Now, specific to AKS, you need to provision resources, right? The GPU nodes. So there should be a proper permission assigned to create those resources. So those are the steps what you see at this one. The AKS OpenID connector issue. So it's basically granting permissions for a specific managed identity, which is basically kind of a user created provision for this one to go and create the GPU resources for you. Okay, so once you have created those user and proper permission, that's now let's switch to this one. So you will go and write this YAML file, which is basically the same YAML definition what you have been working in the Kubernetes world. Then you will go to the kubectl command, execute kubectl apply. So basically, it will kind of create that custom resource. And let me show you on. So like I said, I didn't had a chance to get a demo environment set up. I have some recording for you. So if you see, I have created the same YAML definition over here. And this one basically is instructing to use a standard NC6, which is kind of a VM type in Azure. And then, if you see at the bottom line, it says Pi 3 Mini 128. So what the KAITO contributors have done is that they have created specific presets. That is, when I want to work with an open source model from the Hugging Face repository, for the Falcon 5 Mini 3 models, the KAITO community has already created a predefined thing, how the models should run on a specific instance. So those are called the presets. So I will say that I want to use this preset. So if you need to find those presets, just go to, so I'm showing you the GitHub repo, okay? Everything is open source, nothing is closed. So if you come to the presets and you see the models, so you will see different models that is currently being supported. So you can go into this one and use it as a reference in the example sections. Okay, so that's one of the example what I'm showing over here. So yeah, let me play through this video. So it's basically applying that one, trying to create a workspace, which is basically your development environment in the cluster. And just, you will see so now if you see, when I execute kubectl get workspace, which is basically a new object because of that CRD deployment. So I'm trying to watch on that one, and it basically, so these are GPU nodes, right? It will take some time for spinning up. It won't be that soon. So if you see, it took around 11 minutes to the whole provisioning. So this column says, is that my GPU instance ready? Is it available for inference? So once it's ready for inference, it basically will give you a service endpoint in your Kubernetes cluster. So if you see, I got an external IP, and then I then go to this endpoint for the inferencing. So what you see on the screen is basically a Streamlight application, which is a Python-based application to talk to your endpoints for inferencing. So I just copied that service endpoint, and basically I'm trying to chat with that model which has been deployed. So my first question is, what is AKS? Can anyone tell what is AKS? Right? Azure Kubernetes Service. So let's see what the chat replies back. What happened? It gave us an answer, but it's not relevant, right? Everyone knows AKS means Azure Kubernetes Service. But what it gave us back is that something random jargons over there. Also don't know. So that's one of the problem working with open source models. it's not trained with your data. So it doesn't know what AKS is. It just gave you the information on which it was trained for. So now that's the challenge. We need to go and retrain these models to talk to our data. So that's where the second part comes. So now we are kind of extending that YAML definition. Now, but if you see, now we have a new section, tuning. So the section is how it defines what needs to be done for my training. So I'm saying that I need to tune my model, basically using a method called Kubernetes, which is basically a method developed by Microsoft for training purposes. So if you see, this queue has jumped now because I need to train my data. So there is a need for some other specific GPU instance. So I'm just changing the instance type over there and just saying that, okay, when you run this CRD, custom resource, I also need to train my data. And the fine-tuning what I'm doing is basically in a different workspace. So I'm just creating another workspace definition. So what it will do is that it will start up that GPU instance, and then using the model which you have specified, it will start, and you need to pass your data to it to train on with. So you will basically tell that this is my set of data that you needs to get trained on. So it will run as a Kubernetes job in your cluster, and that's how the setup would look like. So in this case, I'm basically saying that I need to start with Pi3 mini model, and which is running basically as a container. So once the training has been done, you need to save that data, right? So as we are working in an ecosystem which deals with container, so basically when you run anything in a Kubernetes, you are already running it as an image somewhere, storing it as an image and pulling it down. So why don't we use the same format to train the model and save that data also? So what we'll be doing is that once the training happens, that model which has been generated will be basically turned into a Docker image, container image basically. And then you can save that image somewhere in your internal repository. So let me start with another just screen share. So at this step, I'm basically creating a ACR, which is Azure Container Registry, to store my image or model that will be generated. So once that has been provisioned, what I'm saying is that I need to use the instance type as this one. And if you see in the tuning part, I'm passing URL something from Hugging Face, because that data set what I'm using is open source already. You can change this URL to something your internal repository to train the data, train the model on your data. So this is the part which will get changed for your environment, which is specific to your data. Just for example, this one I am referencing directly from Hugging Face. And at the bottom, if you see, once the training has been done, I'm saying that my output should be saved as an image in my container repository. So I just deployed that YAML, and if you see the instances coming up, so once the workspace is ready and the inference endpoint is available, we can basically go and chat with the data. So let me take a pause over here. So if you see when that instance came up and it started training with that set of data what I passed it, So it's showing you from where that data came from, and it got mounted into a cluster. So basically it goes and trains on this data. So there's something concept called adapters over here, where you can basically plug in different models what you have generated out of that training. So you can deploy, let's say you have 2 different data sources. So that's how you can make use of the adapters thing. So now I'm doing the same thing. It's basically creating that workspace for me with the inference, and so now it's the inference part. So that once my training has been done, that model has been converted to a container image, I'm basically deploying that workload into my Kubernetes cluster. So if you see, it will basically spin up a new instance for you. So that pod deployment is coming up, and within few minutes you will see that running. So now that pod got started, and if I look at the service endpoint and go and hit to that one now into my Streamlit application, so basically I'm pointing to my inference endpoint, and I just ask the same question. So now it's giving you the proper context. So it's answering properly for you now. So if you see, we just pulled an open source model, brought it into our environment, just with a few parameter definitions which KAITO provides. You basically ran it on your cluster. Then just tweaked some other parameters which is for training purpose, and then another YAML definition for talking to the same model that has been generated. So if you see, we have taken out that whole complex thing which is involved at the back end for you to understand. So you don't need to go and do that study, like if for this model to work, what GPU instance needs to be done, taken into my cluster. So all those things are taken care by the KAITO project in that definition what you saw in that GitHub repo. So as it's an open source project, you can go and look into the roadmap. It's actively being developed. And if you need to learn more about KAITO itself, so we have an engineering blog which is basically coming from the product team itself who works on the AKS cluster. So you can see the blogs over here. And just to make this, I don't know how many people know the OpenAI ChatGPT thing basically runs on a Kubernetes cluster. So we can definitely vouch on that one. It will definitely work. But the thing is that we need to know how to work with it. That's the part we need to crack. Okay? So yeah, that's all from my side. Thank you, everyone. And by the way, it's an open source project, so if anyone is willing to contribute back, there's a project over there.
Yeah, just for your extra information, KAITO is actually sandboxed by CNCF right now. So yeah, something like in dev or staging per se, right? So hopefully you'll go into production. Right, let's move on.
Any questions?
Can we use KAITO for training the big models like 3 million, 1 million parameter models?
So anything you refer on the hugging phase, that can be done. So right now, if you see on the screen, these are the models which are supported. So slowly we will be adding more one to the list.
How long will it take to try Llama 3 model?
Llama 3. So whatever I showed you on the demo was the thing. So if you have a
micro model.
Sorry?
Whatever you shown is micro model.
Yeah, those. So I picked, I think, 5.3 model from there. So right now, KAITO only supports these models, which are available from the Hugging Face. So if you are talking anything outside of that, that's not possible right now.
Okay.
So the other way to deal with this, you go and understand the KAITO, write a CRT for yourself.
Okay, thank you.
Just a question looking at your demo that which you asked what is AKS?
Yes.
Right, so basically it's like asking a computer scientist like what is an RAM? He's going to answer random access memory, but if you ask a chemist, he's going to say relative atomic mass.
Oh,
right?
okay.
So don't you think like just put a little bit of more tokens in there is going to improve the output?
You mean pass? Sorry, the last part I didn't.
Okay, so as I mentioned, like if you ask a person who's a chemical engineer what is an RAM, he's going to say a relative atomic mass.
Yeah.
If you ask a computer guy, a software, he's going to say random access memory. So you think if you add a little bit of more detail when you're asking the question?
No, so that's what. So when I asked first time that question, it didn't knew anything. So the model which I was using initially, it had no clue about what is AKS. So the training data which was provided to it, even if you add more context to it, add more like prompts, you enhance your prompts, it will give you answer only within that set of data which it was trained for.
Okay.
So
So basically, it isn't like an RAG model right now.
No, it's not. So that's work in progress for this one, kind of. Yeah, it's not there.
How about the scaling?
Scaling in terms like you.
Let's say if I want to run
So that's what I said. You have a need to run the model, so you will create your workspace. Okay, you develop models, train the models within that workspace. So
I mean, if we are training one model, we are already pushing into ACR, right? So
Yeah.
we can use the same model for a number of instances.
So that you can run out of this KAITO thing because you have trained already, right? Within KAITO itself, I'm not right now.
I mean, you are saying once we train the model, we can still be pushing that model
So
into
yeah,
ACR.
what I know is that right now within the workspace only you can work. The scaling part is I'm not aware of it right now. This side, sorry, I've been biased on that side.
Any other questions from members of the floor? From the right? No questions from the right, so be quite quiet. We have one over here. It's good.
Let me take this side.
Yeah, so was previously built Olama locally, so I was thinking of KAITO.
Okay.
Is it able to work locally?
No, not locally.
So only
So your local development would be starting with Olama, which basically is a small thing on your machine.
Yeah.
Your machine won't have that GPU instance, right?
Yeah,
So that's where you need to push to the cloud for that to.
How about a strong server locally, like a Proxmox server?
So then so that templates which I showed you, like the pre-defined templates, you will have to basically write that custom because those are only available for clouds right now.
Okay, so only Azure.
So when right now it's Azure, but the project has it's willing to open up for other clouds also.
Only cloud.
Only cloud. Yeah.
Thanks a lot for the great talk. I want to ask about examples that you have seen where people needed to actually fine-tune and train their own model.
So the example I showed is...
Other than internal knowledge graphs, like if it's internal documentation, etc., that they would need to fine-tune their models on. What other examples do you see actually in production where people are fine-tuning their models?
Truly speaking, I haven't worked on any project yet, but it's all my learning purpose. This is what I've explored. But I can get you that answer later.
Thank you.
Okay. Sorry about that.
All right. Any other questions?
I won't hallucinate.
Oh, okay. All right. We have one more.
Hello. Okay. It's not related to KAITO itself, but how do you guys handle the versioning in the GitHub, like from GitHub to provisioning and to deployment? So is there like an automated system for your versioning?
You mean the project itself or the models?
No, the project itself. Like there's like a release, right? Version 0.3 point something, right?
So if you go to the roadmap, okay. So here the to-do, basically all the PRs which are generated got revived within the team. It comes into to-do. The team prioritizes and then goes into in progress. So once it's in progress, those which has been developed already is bunched together as a specific version. So those are prioritized by the engineering team. So they will know like what is the ask from the customer or what the community is looking for. So they will bunch all those features together and that will become as a release. So that will go basically automated deployment then.
What would be the tips for everyone to contribute, like how can we contribute to this project?
So to start with, it's generic for any open source project, right? You go and read the documentation. Documentation will be the first place to start with because that will make you understand how the project works. And if this is basically a code-based project, if you are proficient in that, pick up that project and start contributing. So if you go to the issues one, that's the place to start with. You go and look into the issues, what people are trying to solve, okay? What's their pain point. Pick the smallest one but you can contribute to. And that's how you get involved into it. That's generic for any project, not just KAITO. Yes, so the CNCF is a good, Kubernetes is a good place to start. So I started with Kubernetes documentation, and then a little bit on, and then I left. That's, I shared my idea. I think, then. Okay, thank you everyone.
All right, lot of applause for contributing. Okay, reach out to us guys. So if you guys have any sponsors, any places for food, we are in need of sponsors. So make sure you guys know, let us know, any kind of presenters if you guys have, please just let us know. We are,
for additional PlayStations.
Yeah, we'll make sure that we'll ask Nagesh for, more PlayStations next year. Alright?
Xbox next time.
Yeah, Xbox or anything. Xbox for Microsoft.
Steam Deck.
Okay. Alright. So before you guys fill in the survey, I would like to thank Microsoft and also Moneyline for sponsoring today, as well as not to forget Nagesh, and thank you guys, thank you everyone for actually attending today, making time for everyone. I know it's late at night and stuff. Alright. So hope you guys learned a lot, and again, as always, take care. Have a good day. Group photo. Yeah, let's take a group photo. Group photo, everyone.